everyone, and welcome back to the UAV Understanding Drones course. Let us take a quick recap of what we have learned in the previous section. In the previous section, we learned about the UAV definition, their classification on the basis of size, on the basis of degree of autonomy, and on the basis of range and endurance, and their configuration such as fixed wing, hybrid, single rotor and multi-rotor. Now in this section, we will learn about the operating principle of drones and their parts and configuration. So let's get started. What do you understand about the term drone? Well, drone stands for Dynamic Remotely Operated Navigation Equipment. For the definition, a drone is a flying robot that can be remotely controlled or fly autonomously through software-controlled flight plans in their embedded systems, working in conjunction with onboard sensors and GPS. The multi-rotor UAVs or drones have the rotor systems generally carrying 3 or 4 propellers that are capable of vertical takeoff and landing and hovering over an area while carrying a sufficient payload. So let us learn about the principle behind the working of drone. The relative nature of the force means that when the rotor pushes the air also pushes the rotor back. Recall Newton's third law. Every action has an equal and opposite reaction. The action here is the rotor pushing the air and the reaction is vice versa, that is air pushing back the rotor. This is the basic principle that the drone can go up and down. Furthermore, the faster the rotor rotates, the greater the lift and vice versa. The subject of fluid dynamics plays a significant role in the design and development of aircraft and drones. A sufficient amount of upward force is required to lift the vehicle against gravity, which is named lift. A force created to move the vehicle or body in motion is called thrust. When air flows over an airfoil, pressure, viscous and drag forces act on the profiles. Force is directly proportional to the velocity of the air at the inlet. The flow pattern around the cross-section of the propeller is shown below. High fluid pressure at the bottom and low pressure at the top of the propeller causes an upward force which is called lift. This force is responsible for lifting the weight of an aeroplane or drone. The amount of lift force depends on the angle of inclination of the airfoil or propeller. Based on the principle of conservation of energy in fluid flow, that is Bernoulli's principle, the sum of all the forms of energy in a fluid is constant along the streamline. When air flows over an airfoil or wing, its velocity increases at the top portion, but the pressure of air decreases. The air velocity decreases and pressure increases at the bottom side of the blade. The next pressure difference across the airfoil results in an upward force which is called a lift. In simple terms, 4 forces act on any aircraft while flying: weight, lift, drag and thrust. Weight due to gravitational force needs to be balanced by lift for an object to fly or at least remain afloat. If pressure at the top is lower than the pressure at the bottom, the aircraft moves in an upward direction. The drone is therefore designed to be lightweight. Thrust or forward velocity depends on the shape of various parts like wings. Drag force slows down the aircraft by acting in the opposite direction of motion. It is necessary to understand how the aerodynamics of the airfoil of the aircraft's wing acts. So see you all in the next lecture where we will learn about the brief history of drones.